The first thing that we need to do to solve this rational equation is identify the least common denominator. Because this x term in the middle here is really x divided by 1, we see that the least common denominator of all of these terms is x minus 3. Once we identify the least common denominator, we multiply both sides of the irrational equation by the least common denominator. Now we distribute on both sides. So let's start with this first piece. X minus 3 times x divided by x minus 3. You'll see that the x minus 3 on the top cancels with the x minus 3 on the bottom, so this product here is just x. Now we do x minus 3 times x divided by 1, and that's simply equal to x times x minus 3. And now we do x minus 3 times 3x minus 4 divided by x minus 3. The x minus 3 on this top cancels with this x minus 3 on the bottom, so we're left with the top, which is 3x minus 4. The next thing that we want to do is distribute the x in this term right here. X times x is x squared. X times negative 3 is negative 3x. Now we want to collect alike terms. X minus 3x is negative 2x. So we have x squared minus 2x equals 3x minus 4. Now that we have a quadratic here, we always want to put our quadratic equation in standard form in order to solve it. So we have to subtract 3x from both sides. And so we get x squared. Negative 2x minus 3x is negative 5x. And on this side we're left with a negative 4. Next we need to add 4 to both sides. So we have x squared minus 5x plus 4 is equal to 0. Now we just have to factor. X goes in the first slots. Because this sign is negative and this sign is positive, we know we have a minus in both of these spots. Next we need two numbers whose product is 4. 1 and 4 will do the trick. So from this here we see that the solutions are x minus, well, we use the zero product property now. So x minus 1 has to be equal to 0, which means x has to be equal to 1. And x minus 4 also has to be equal to 0, so x must be equal to 4. What we need to do now is to check to make sure both of these solutions work. Okay, we need to check for extraneous solutions. In order to do that, we need to plug both of them back into the original equation, which was x over x minus 3 plus x over 1 equals 3x minus 4 divided by x minus 3. I'll let you guys do that on your own. Okay, let's do another one. Okay, once again, the very first step is to find the least common denominator of all the terms. Okay, in order to do that, we need to make sure every single denominator is factored. You see that this middle one here isn't, so we need to factor it. x squared plus 5x plus 6 factors as an x in the first slot, plus and plus here mean plus and plus here. And finally, two numbers whose product is 6, 3, and 2 are the ones that we want, so we get a middle term of 5x. Of course, the fact that we have an x plus 3 and an x plus 2 in this problem are a big hint that x plus 3 and or x plus 2 are going to be involved when we factor that quadratic. Okay, so now we want to identify the LCD. Because of this x minus 3, we know we have to have a factor of x minus 3 in our LCD. Oops, I'm sorry. That should be a plus. Okay, because of this x plus 3 here, we know we should have a factor of x plus 3 in our LCD. And it should be raised to the first power because both of these x plus 3s are being raised to the first power. Next, because of this x plus 2 and that x plus 2, we know we have an x plus 2 in the LCD. And once again, it should be raised to the first power because this x plus 2 and this x plus 2 are both raised to the first power. So x plus 3 times x plus 2 is our least common denominator. Now we want to multiply both sides by the LCD. Okay, so now we've multiplied both sides of the rational equation by the LCD, so we need to distribute. Okay, let's go to this first term. X plus 3 times x plus 2 times x minus 1 divided by x plus 3. You see that this x plus 3 right here will cancel with this x plus 3 in the top right here, and we're simply left with x plus 2 times x minus 1. Next, we move on and distribute it to this guy. So the x plus 3 cancels with the x plus 3 in the bottom, and the x plus 2 in this top cancels with the x plus 2 in this bottom. So we're simply left with 4 in this piece. And finally on this side, the x plus 2 cancels with the x plus 2 in the bottom, and we're left with x plus 3 times 1, or just x plus 3. Now we need to FOIL right here on this piece. So x times x gives us x squared minus x plus 2x gives us plus x. Finally, 2 times negative 1 gives us negative 2. And then plus 4 equals x plus 3. Okay, we should combine these two like terms of negative 2 and 4. Gives us a plus 2. Finally, we should bring over the negative x and the 3. So we have minus x. X minus x is 0, so that term drops out, and we have plus 2. 3 is left on this side. And finally, we subtract 3 from both sides. So we have x squared. 2 minus 3 is negative 1 equals 0. Now all we have left to do is factor. X squared and 1 are both perfect squares, and that means that x squared minus 1 is a difference of 2 squares. So it factors as x plus 1 times x minus 1. Okay, once again we use the zero product property. We set each individual factor equal to 0. So x plus 1 equals 0, or x minus 1 equals 0. So the value we get from x plus 1 equals 0 is x equals negative 1. The value we get from x minus 1 equals 0 is x equals positive 1. And once again, I'll leave you to check these two solutions in the original equation of x minus 1 divided by x plus 3 plus 4 divided by x squared plus 5x plus 6 equals 1 divided by x plus 2. Okay, so if you plug in 1 and negative 1 to the x's here, both sides of the equation should balance. And if they do, it means neither of them are extraneous solutions, and they both work. Okay, so I'll let you guys do that.